This is for question number 3. We have a difference equation. I've been asked to sketch it, so I've gone into difference equations. Here it is, it's drawn the force field. I've placed the initial condition of 0, 1.5, which is what I was told here. And it's drawn it for me, so I've just sketched it onto the curve, just like that, for 1 mark. In the second part of the question, solve the difference equation and show that y equals, so I've taken my difference equation and I've put it into desolve using the changed initial condition, because now I have y equaling 1 when x equals 0, and that came up with my difference equation. So in my equation, y equals e to the minus x squared. Over the page, the coordinates of any points of inflection. So what I've done is I've made sure that I had points of inflection. So I've opened up a graphing window. I have taken the expression which is e to the x squared. If I go analysis, G-solve inflection, it will find the points of inflection. And I can see that there are 2 of them, but they don't give it to me in exact form. So here I've set the second derivative equal to 0. So I've got the second derivative, set it equal to 0 and solve, and I get my 2 answers, or plus or minus root 2 on 2, sub it into the y value to get my coordinates. Part B, consider the family of curves. I've got y dx now is minus kx squared, and I need to use implicit differentiation. So with the implicit differentiation, I have used minus kx as my first term and y as my second. So the derivative implicitly of this will be minus, well, to do the y first, so minus kx times y dx, so there it is there. Then the derivative of minus k is minus k times y. And I have replaced my dy dx with this expression for dy dx. So that goes where dy dx is in here, and then I've taken out common factors, and there's my expression for dy dx in terms of y and x only, because I replaced my dy dx with what dy dx equals. Hence show that it doesn't matter what the k value is, the same y coordinate of the point of inflection occurs. So I've set the second derivative equal to 0, but I've used this expression here, which was the expression from the last question. Setting that equal to 0, I get x equals plus or minus root 1 on k, and when I sub that into the y coordinate, I end up with something that, irrespective of k, I end up with the same value. So that means that it's the same, irrespective of what the value of k is. And that's that question, question number